Hey there, PreCalc. Here we are with another wonderful educational video for you. Talking complex numbers today, AX plus BI. All right. Where do these imaginary numbers come from? The depths of Mr. Handke's brain and imagination? No. They come from square roots of negative numbers. All right, you've learned about these in Algebra 2, so I'm not going to bore you to death here with all the math mumbo-jumbo. Just the square root of I, or the square root of negative 1 is I squared is back to negative 1. When you combine real parts with imaginary parts, we have complex numbers. A plus BI, or AX plus BI is what you've seen before. Real part, complex part. We're just worried today about doing math with imaginary numbers. So if you want to read all the math mumbo jumbo, you can do that. I'm here to translate and get you to the good stuff. What do you need to know how to do? Alright, so when we're adding and subtracting, super easy. Real part with real part, imaginary part with imaginary part. So we got 4 plus 1. 4 plus 1 is 5. Imaginary part with imaginary part, 7i plus negative 6i is plus 1i, or just I. Subtracting, okay? Now, if you want to distribute this negative sign, change this to a plus and push that negative into both parts, if that works best for you, go ahead and do that. Otherwise, the way it's set up right here, I'm just going to say it to myself. I'm saying it out loud, obviously, for the video, but if you would maybe say this in your head, 1 minus 4. 1 minus 4 is going to be negative 3. And then the imaginary part, 2i minus 2i is 0i, or just negative 3. So if you just look at real minus real, imaginary minus imaginary, you can kind of do it that way, or if you want to push it all the way through, you can push it all the way through. Okay, this part gets a little tricky. I think I'm going to push these through. There's more than one. They're not necessarily in order. We have imaginary, then we have real imaginary, real imaginary. Let's just push this through. Boom, boom. So we're going to have 3i plus 2 minus 3i. Cancel that out now before I forget. 3i minus 3i. See you later. Push this one through. Minus 2 minus 5i. Okay, plus 2 minus 2. And all we're left with then is minus 5i. So we had 0 minus 5i, or just negative 5i. All right, another one here. Let's push pause and let's see if you can figure this one out on your own. Ready, set, go. Okay, another one with multiple parts. I'm going to suggest maybe pushing this through. Minus 7 minus I. This one's addition, so not a big deal. So real parts here, we got 3 plus 4 is 7. Minus 7 is 0. 2i minus 1i is down to 1i. Minus another I. An I for an I. Leaves everyone blind. 0i. Or just straight up 0. Okay. Blah, blah, blah. More math. Okay, if you want to read all that stuff, you can read all that in the book. Let's just keep doing these examples. Okay, if you want to read all the technical math terminology, you can do that on your own. Multiplication. And writing it in standard form, which is A plus BI. So, multiply it through. 8i times 4, we're going to have 32i. 8i times negative 3i, that's going to be negative 24i squared, But wait, I squared is negative 1, which flips this to a plus 24. And then if I put the real part in first, so I'll go a little slower here, especially for this first one. 32i minus 24 times negative 1, right? I squared was negative 1. Okay, that's going to be 32i plus 24. And then put it in the a plus bi form, the real part first. 24 plus 32i. All right, that's what I was kind of thinking about right here, jump into this. But I could see where if I just did that, I might lose a few people, especially on the first one. Okay? So take a second to let that sink in. What do? 32i minus 24i squared. I squared is actually negative 1. Negative 1 times negative 24 is a plus 24. Okay, we want the real part first, the imaginary part second. There we go. Okay, let's FOIL this out. 3 times 5 is 15. Then we'll have a plus 12i. Negative I times 5 minus 5i minus 4i squared. Okay, so we got 15. 12i minus 5i is plus 7i. Negative 4i squared, so I squared is negative 1, which then flips this to a plus 4. And then our final answer is 19 plus 7i. All right, let's have you try 2 plus 4i times 2 minus 4i. That's a little bit of a lead-in here, foreshadowing to something we're going to be doing soon. Let's have you multiply that out on your own. Okay, let's see how we did. 2 times 2 is 4. We'll have minus 8i and plus 8i. Isn't that something? So those are going to wash out. Minus 16i squared. I squared is negative 1, which turns this to a positive 16. 16 plus 4, just a straight up 20 for our final answer there. Okay, keep it going. You got D on your own, 5 minus 3i squared. Might be tough to think about it in terms of our math shortcut for squaring a binomial. Maybe you want to take the safe route and write it down twice and FOIL it out. Ready, set, go. All right, let's check it out. So I just write it down twice. 5 minus 3i. So there's 25. Minus 15i. Minus 15i. Plus 9i squared. So I guess it's still going to work out to kind of like square the first, square the second, 25, plus 9i squared, and then multiply those two together and double it. Minus 15i, double it, okay? But then you still have to think about what this is going to do. So that's where it's different. So plus 9i squared, I squared is negative 1, changes this to a minus 9. 25 minus 9 is 16. Minus 30i. So the final answer is a little bit different from what we're used to with our binomial squaring shortcut of square the first, square the second, multiply these two together and double it. But I mean, you could get it started with that at least, but just know that there's another step after it. All right, so what we did up here in C was actually complex conjugates. Same numbers, different sign between them. And what happens then is all the i's should cancel out. Should cancel out. All right, so 1 plus I. What would be the complex conjugate to that? The same numbers, different sign, 1 minus I. Same numbers, different sign. All right, let's multiply that out. 1 minus 1i plus 1i. All these I for an i's. minus I squared. So minus I plus I squared is negative 1, which flips this to a plus 1. 1 plus 1 is 2. All right, we getting that? This is minus negative 1. I squared is now negative 1. Minus a negative 1 is plus 1. 1 plus 1 is 2. Okay, you try B on your own. 4 minus 3I. What is the complex conjugate? And then multiply it out. Okay, welcome back. Let's see how we did. 4 plus 3I. 16 plus 12I minus 12I minus 9I squared. I squared is negative 1. Flips this to a plus 9. 16 plus 9, 25. Okay, so why would I use this complex conjugate? Okay, so when we're dealing with rational expressions with imaginary numbers, okay, just like it's not good math grammar, not proper math etiquette to have square roots in the denominator of your answer, it's also not good to leave imaginary numbers in the denominator of your answer. So, let us fix it, if you will. 2 minus I on the bottom, so I'm going to multiply to 2 plus I, top and bottom. Now, I'm doing 2 plus I, not because that's what's on the top already up here, but because that's the same numbers down here, different sign in the middle. That's why we're doing it, not because it matches up here. I don't want people thinking, oh, he picked 2 plus I because that was what was on the top. Nope, I'm picking 2 plus I because it's the same numbers as the bottom with a different sign, 2 plus I instead of 2 minus I. So that should take care of our denominator, right? It's going to be 4 plus 2I minus 2I minus I squared. Okay, on the top here we'll get 4 plus 2I plus 2I plus I squared. Okay, I squared on the top is negative 1. 4 plus negative 1 is 3 plus 4I. On the bottom, that's why we picked this. Plus 2I minus 2I cancels out. And then I squared is negative 1. Minus a negative 1 is a plus 1. 4 plus 1 is 5 on the bottom. Okay, I'm okay with you leaving it like this. The book does say in standard form here, standard form would be 3/5 plus 4I over 5. They want them separated out, real part, imaginary part. I'm okay with 3 plus 4I all over 5. Okay, more math mumbo jumbo. Okay, dealing with the square roots of negative numbers. So when you're simplifying this, they want you to pull out the negative, do the negative first, all right? Don't multiply this together and call it the square root of positive 28. When you're simplifying this, they want you to take the negative part out. What am I saying by the negative part out? Okay, so we'll go super slow motion. This is the square root of negative 1 times the square root of 14 times the square root of negative 1 times the square root of 2. Okay, that's what they want you to do. So like I square root of 14 times I square root of 2. So I wouldn't have done this step in like a normal showing of my work. I wouldn't have done that step. I would just go from here to there. I square root of 14, I square root of 2. Now I'm going to multiply the i's together. I squared, square root of 28. Okay, how can I break this apart? I squared is negative 1 times the square root of 4 times the square root of 7. Okay, reducing radicals. This is like an Algebra 1 geometry skill. We're looking for perfect squares that go into here. 4 is the biggest perfect square that goes into 28. Square root of 4 is 2. Negative 1 times 2, negative 2 radical 7. Final answer. Okay, let's try the same thing over here. So we got I square root of 27 minus I square root of 12. What's the biggest perfect square that goes into 27? 9. 9 times 3. And the biggest perfect square that goes into 12 is 4. Okay, so we have 9i radical 3 minus 2i radical 3. Perfect. Okay, they have the same root, so I can subtract them. They have to have the same root to subtract them. This is like an x, right? You couldn't do 9x minus 2y, but if it's 9x minus 2x, you can do that. 7i radical 3. No, this is the square root of 9, Mr. Handke, is 3. 3 minus 2i is 1i radical 3. Square root of 9 there, 3. Why didn't you tell me something? Should have let me know. I would have stopped. It's a joke. I know it's a video. Alright, negative 2 plus the square root of negative 5 squared. So we got negative 2 plus I radical 5 squared. So times itself. If you don't want to do the squaring thing, you can just write it down twice and FOIL it out. I find that's actually the safest thing to do with many of these problems, because kids think they get the shortcut down and then they mess it up. So negative 2, that's positive 4 minus 2i square root of 5 minus another 2i square root of 5 I squared and square root of 5 squared. So I times I is going to be negative 1. Square root of 5 is square root of 25, which is 5. Okay, I times I is negative 1. Square root of 5 times square root of 5 is regular 5. That's going to be a negative 5. Minus 4i radical 5 minus 5. And there we are. Whew. Alright, so far it hasn't been too bad, right? It hasn't been too bad. Just the toughest part is that you were dealing with imaginary numbers. Right? You have to keep track of I. Now, we move on. There are going to be some not nice problems dealing with the quadratic formula. Okay, so x squared plus 4 equals 0. Zoom out so I can fit this in, or maybe just slide this up over here. Okay, so there's no other x, it's just x squared, there's no regular x, so you could put a 0x in there and try to FOIL or factor it and solve, or we can just go x squared equals negative 4. Okay, now depending on what chapter you're in your math book, sometimes this is no solution and sometimes you have to do imaginary numbers. The lesson is on imaginary numbers, so you're going to have to use imaginary numbers. X equals plus or minus 2i. Square root of 4 is 2, the square root of the negative is I, plus or minus 2i. Last one. This is not the fun one. You can sit there and try to factor this out. It's not going to happen. Okay? So we need to do the quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. A, b, including the sign, c. So negative of a negative 2, negative 2 squared, 3, 5. 2 times 3. Okay, super important to make sure we get all this stuff put down in the right spot. Alright, so negative of a negative 2 is a positive 2. 4 minus 12 times 5 is minus 60. Let's see, where can I squeeze this in? 2 plus or minus the square root of negative 56. Okay, so what goes into 56? 2, 28, so 4 will work. 4 is going to go in there 14 times. So I'm going to split this up into 4i and 14, or not 4i, negative 4 and 14. That's how I'm going to think of it as. So if I think of this as negative 4 times 14, so that's going to be 2i squared root of 14 over 6. Okay, 2, 2, 6. So this is a plus or minus, right? This is addition. You can't just cancel just part of it. It has to go into both parts up top. Okay, so let's split this apart first. Sorry, let's split this apart first. So this is 2/6 plus 2i radical 14 over 6. So that's why you'd have to be able to reduce both parts. That's what this is. All right, so this is actually 1/3 plus or minus I radical 14 over 3. Whew. Okay. A lot of times people will see like a 2 here and like a 7 over here, but still reduce right here and call it 1/3, 1 plus 7 over 3. Okay, it's really, if it's a plus, it's got to be able to go into both. Plus minus, you got to be able to reduce both at the same time. All right, folks, another long one, 22 minutes. Hopefully that wasn't as mentally taxing as the last one, but there you are. Good luck on your work, and let me know if you need any help.